Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you people about the conversion of NFA to DFA. Let me project some basic steps how the conversion of NFA to DFA can really happen. As you all know the difference between NFA and DFA. So now NFA can accept an empty string but DFA cannot. NFA can pass one input to other state multiple times, more than one times, but DFA can't. So in order to use these particular aspects, we are making this NFA, which is actually converted into DFA by using this following steps. Assume that let's Q be a new state and Q is always called to be a null in a starting state. And let us assume T be a new transition table of any given DFA. Now step number 2, when the possible process of the step number 1 has been happened, then this step number 2 is actually begins. It adds a new state in Q. Q you all know that is a new state, and add the transition of that particular state in a table called T. So let me take you to the basic example how this conversion is actually happen. Now convert the following NFA to DFA. This is the transition diagram representation. As you all know that NFA, how it differs from DFA. Now say for example, let us draw a state transition table to accept all the input from the transition diagram. Now I have represent state Q1, Q2, Q0, Q1 and Q2. This arrow represents it is a starting state. This star represents it is an end state. And I have mentioned it as an alphabet, and also it is called as an input. That is A and B. That is the two different inputs I have been used here. Now let me explain you how this transition table works. Now Q0 passes an input called A to itself. So I have mentioned Q0 here. Again B. Let us see whether Q0 is passing the input called B to any other state or else by itself. Now you can see this diagram. It is passing to itself and it is passing to Q1. So Q0 is passing the input called B to itself and Q1. So that is the representation. I hope you understand how this particular transition diagram is actually constructed. Now let me take you to the second process, that is Q1. Now Q1 doesn't have any input called A which is passed to the next state. So I have represent it as empty. Now let me check what is the other input which is passed by Q1. Now it is passing B to Q2. So I have mentioned this B is input which is actually transacted from Q1 to Q2. So this is the end statement where the B is projected to be N. So it is Q2. Now what is the other state we have? That is Q2. Q2 doesn't have any inputs which has been passed from Q2 to any other state. So it is initially mentioned as null state. Now this is the regular state transition table for this particular given NFA. So let me take you to the next possible step. This is step number 1. Now what we are supposed to do? We need to have, let Q be a new state, that is a set of state of a DFA. And second possibility, I have already told you, we are going to construct a new transition table which is actually defining our project into DFA. Now again, let me show you the step number 2. Now the step number 2 is resembles about add transition of states. Now say for example, state is already we have represented, the alphabet is A and B, or else we can call this alphabet as input, that is A and B. Now Q0 is a starting state, so I have represented with this arrow, and we have Q0 has been passed with only one input that is called A, and now I have represented the same. Now again B has been passed. I will show you the diagram also here. A is passed, again B is passed from Q0. So I have drawn this diagram in this way and this transition table. Now we are getting a set of state that represents here, that is Q0 comma Q1. It is a set. Now this represents a new set of state that we are going to have the conversion of DFA, that is from NFA to DFA. This is step number 2. Now this is a new particular state. So this state will be called here actually. Let me show you how it is happened. See here, Q is called a new state, set of state, not a state, it is a set of state, that is Q0 comma Q1. So add transition for this set. So I have added. So you can see here Q0 comma Q1, it is a new set of state. Now let us see how this particular thing resembles here. Q0 I have already explained, so I don't want to touch this particular port again. So I am going to this Q0 comma Q1. So again, let me show you this particular transition diagram. That is Q0, how all the inputs is passed through from Q0, right? So now you can check it over here. That is Q0 comma Q1. How this Q0 comma Q1 is passing this input called A. So Q0 is passing in this particular set. Any one of the state is passing any input, so we need to represent. So in this particular state, we can see Q0 is passing this A to itself. So this is a diagram I am going to represent. A is passing Q0, so Q0 has been represented. Again, Q0 comma Q1 is representing B or not. You can see here Q0 is passing this B to itself and passing this B to Q1. So this particular transition diagram can be represented as, table can be represented as Q0 comma Q1 is passing B to itself to Q1 and Q1 is passing the B to Q2. So this particular input called B is passed by three different states. Now you can see here again, I am showing you the diagram. Q0 is passing B to Q1 itself and Q0 is passing B to Q1 and Q1 is passing B to Q2. So I have represent that particular state here, Q0, Q1 and Q2. Let us check whether this state has been already constructed or not. No. So we are going to take this as a new state. So what is the rule? We need to have the new state again. New state will be added with the present state. Now this Q is called as the new set of state, that is Q0, Q1 and Q2. This is the new set of state we have received. Now let me project. First step, we know already how it happened. Second step, just now we have solved, we know how it happens. Now let me take you to this new state called Q0 comma Q1 comma Q2. Whichever state you have here, that has to be taken to the new state, and we need to project and we need to pass the input and we need to check whether we are getting one more new state or not. Until we stop. When we are going to stop, when there is no state, that is no new state you are finding, then assume that you need to stop exactly there. Now see here, Q0 passing this A to itself. Again, Q0 is passing this B, so Q0 is here. Q0 is passing this, Q1 is passing this B, so Q1 is here. And Q1 is passing this B to Q2, so Q2 is also here. Now you can check it. This is the state, but it is not new, which is already arrived. So that means if we are keep on getting the same state again and again, the access has to be stopped because there is no possible new states has been arrived. So exactly I am going to stop it over here. Now in this projection you can see that there is no new state or left to be added in this table, transition table called T. So we stop here. Now how does the final transition table for DFA looks like? Now see here, we have derived this particular Q0, Q0 comma Q1, Q0 comma Q1 comma Q2, right? This is Q1 and this is comma Q2. Now you all know I have represented this arrow symbol for the starting state, and wherever this Q2 represents, Q2 in the sense it is the end state, as you all know. So I can show you the diagram also. Q2, whichever the set which has this Q2, the whole set we can call it as an end state. So we are representing the star wherever the Q2 is represented. Now let me show you how this particular DFA may be drawn as. So this is the one sample diagram. We can also use multiple sample diagrams to draw the same different aspects. So now I have used this particular thing. As you all know, there is no null set and there is no possible way of taking the same input again and again by DFA. Now Q0, so I am going to show this particular thing. So Q0 is taking an input called A, here it is. Again Q0 is passing this input called B to Q0 comma Q1. So you can see here Q0 is passing A to itself and it is passing B to Q0 comma Q1. Now here comes the DFA. There is no repetition of inputs which is passed by itself, and more than one time it cannot pass the same input. So now this is the first process. Second process, Q0 comma Q1. This is the state Q0 comma Q1. It passes this particular A, the input called A, to Q0. So here it is comes Q0, Q0 comma Q1. It passes the inputs called A to Q0, sorry. Again Q0 comma Q1 passes the input called B to Q0, Q1 and Q2. So now we are going to project all these things. Q0 comma Q1 is passing this input to Q0, Q1 and Q2. So this represents that. So this is how this particular line number 2 represents. Number 3, Q0 comma Q1 comma Q2. This is the end state which is passing A first. As you all know, which is passing A first, and the state is Q0. So here it is. The A has been passed. You can see here. Now what is the next state it is? It is passing B to Q0, Q1 and Q2. So Q0, Q1 and Q2 passing the B to itself. So it represents here. Now the projection of this particular conversion is not to pass the same input from one state to another state, and it is going to restrict. There is no null input can be passed. Thank you.